Operations on functions. Carol owns a store that sells birdhouses. The revenue from birdhouse sales is given by the function r of x equals 125x. The cost of making the birdhouses is given by the function c of x equals 65x plus 5,400. Her profit P is the revenue minus the cost, or P equals R minus C. So the profit function P of x can be defined as P of x equals quantity R minus C of x. We can perform operations on functions just like we perform operations with numbers. We can add, subtract, multiply, and divide functions. Here's the notation for function addition. Here's the notation for function subtraction. Here's the notation for function multiplication. And here's the notation for function division. We'll start with two functions. We have f of x equals 2x squared minus 3x minus 27. And we have g of x equals 2x minus 9. Let's find f plus g of x. We just add all the terms of the two functions together. We combine like terms, so the minus 3x and plus 2x go together, and the minus 27 minus 9 go together. So bringing down everything, we have f plus g of x equals 2x squared minus x minus 36. Now we'll perform the subtraction operation. We have find f minus g of x. Here we have f minus g of x. It is 2x squared minus 3x minus 27 minus quantity 2x minus 9. Note that the entire g of x, 2x minus 9, is inside parentheses. It's because, inside parentheses, because we need to subtract all terms of g of x. We have to distribute that minus sign to everything inside parentheses, and that's shown by the green arcs here. So that becomes f minus g of x equals 2x squared minus 3x minus 27 minus 2x plus 9. Do you see how that 9 becomes positive? The minus 3x and the minus 2x go together, and we have minus 27 plus 9 as well that go together. So all that simplifies to f minus g of x equals 2x squared minus 5x minus 18. Now we'll multiply. Find fg of x as in f times g of x. For this we'll say that fg of x, or f times g of x, is quantity 2x minus 9 times quantity 2x squared minus 3x minus 27. That's a binomial times a quadratic trinomial. Let's multiply this out using the box method. Since it's a trinomial times a binomial, we'll use a 2 by 3 box. We'll place the trinomial on top of the box, which with each of the three terms heading the columns. At the tops of the columns are the terms 2x squared, minus 3x, and minus 27, respectively. And then at the side, heading the rows, we have 2x and negative 9. Multiplying together the terms in the rows and columns where they meet, we have 2x times 2x squared equals 4x cubed in the upper left cell. We have 2x times negative 3x equals negative 6x squared in the center top cell. And in the top right cell, we have 2x times negative 27, which equals negative 54x. In the lower left cell, we have negative 9 times 2x squared, which equals negative 18x squared. In the lower center cell, we have negative 9 times negative 3x equals 27x, as in positive 27x. And in the lower right cell, we have negative 9 times negative 27 equals 243, as in positive 243. We can combine like terms both for the x squareds and for the x's. That gives us a product of 4x cubed minus 24x squared minus 27x plus 243. And that's fg of x, or f times g of x. And now we'll look at the division operation. Find f divided by g of x, or f over g of x. That's f over g of x equals 2x squared minus 3x minus 27 over 2x minus 9. We could try by factoring out the 2x minus 9 from the 2x squared minus 3x minus 27, and that's exactly what we'll do. We'll set up a 2 by 2 box that forms 4 cells. We place 2x squared in the upper left cell, and we'll place negative 27 in the lower right cell. Then we place what we're trying to divide by, 2x minus 9, at the left of the box. One row has the 2x term in front, and the other lower row has the negative 9 in front of it. Now we need to ask ourselves, what do we need to multiply by x to get 2x squared, and place it on top of the box, and that would be x. Then on the top of the other column, we find the value that we need to multiply by negative 9 to get negative 27, and that's 3 as in positive 3. Next we fill out the box to make sure everything's correct. In the top right cell we have 2x times 3 equals 6x, and then in the lower left cell we have negative 9 times x equals negative 9x. And since negative 9x plus 6x equals negative 3x, everything checks out. So we know that f over g of x is x plus 3. And working in reverse, if we were to multiply this function, x plus 3, by the binomial 2x minus 9, we would get the quadratic trinomial 2x squared minus 3x minus 27. We'll end up with a few multiple choice problems. Carol owns a store that sells birdhouses. The revenue equation for her business is given by the function r of x equals 125x. The cost function for the business is c of x equals 65x plus 5,400. If the profit for the business is revenue minus cost, which function p of x best represents profit for the business as a function of sales? Stop the video, solve the problem, then restart the video to see if you got it right. The correct answer is C. This answer is the cost function subtracted from the revenue equation. Now, the next problem. Terry sells potatoes for $5 per bag, apples for $15 per case, and turnips for $10 per bag. Which composite function, s of x, correctly represents Terry's sales for the 3 items combined? Stop the video, solve the problem, then restart it to see if you got it right. The correct answer is C, with the correct number attached to each item. Now for our last problem. One function is represented as f of x equals 2x squared minus 6x. A second function is represented as h of x equals 2x. Find f over h of x. Stop the video, solve the problem, then restart it to see if you got it right. The correct answer is D. F over h of x equals x minus 3. Here are the functions together. 2x squared minus 6x all over 2x. In the numerator, that factors out to 2x times quantity x minus 3. 2x over 2x cancel to equal 1. And that leaves us with x minus 3. So D, again, is our correct answer. This has been Operations on Functions. Thanks for viewing.